Into a new unit, we are talking about trigonometry, okay? You were first exposed to trigonometry back when you took geometry, but it was just a little bit, okay? We're now in pre-calculus, so you guys are going to learn a little bit more about trigonometry. You're going to expand on your knowledge of right triangles today, and you guys are going to learn how to find side lengths and angle measures of right triangles. Some of this will feel like review. Some of this may be new, okay? But we are starting that as we move into our trigonometry unit, which will take us probably into midterms, a little bit after midterms, because trigonometry is a big part of pre-calculus, okay? So, let's get started. Let's talk about the parts of a right triangle. Hopefully you guys do remember the different parts of a right triangle, okay? So, you always know a triangle is a right triangle because it has a what? A 90-degree angle, also known as a, what is it called? A right angle, okay? So you do have your right angle, hence why this becomes a right triangle, okay? And when you have a right triangle, the sides have special names. You guys remember those names? Adjacent, opposite, and hypotenuse. And it was always based off of an angle, an acute angle that was given to you in your diagram, okay? So the side lengths were always based off of the acute angle that was given to you or that you were trying to find inside that right triangle. This side, this one right here, was called, which one of those?
Hypotenuse.
It's the hypotenuse. Remember, the hypotenuse was always located across from the 90-degree angle. What about this one over here?
Opposite.
This one was the opposite, okay? If you were the type that back in your geometry days, you always got the opposite and the adjacent mixed up, think opposite across from that angle, okay? The opposite side can't form the angle that you're given, okay? It has to be across from it, which leaves you with this last side, which is the adjacent. What's another word for adjacent? Beside, next to, right? Beside or next to. So, from the acute angle that's given to you, it's the side that's right beside the angle. It is one of the sides that forms the angle with the hypotenuse. Okay? All of those pieces came together and SOHCAHTOA was created. Actually, I don't know if it was created that way, but that's what they based everything off of, okay? From those three sides, there were different ratios that dealt with sine, cosine, and tangent, which you guys have in your pink foldable. Okay? Sine was your opposite over hypotenuse. Cosine was your adjacent over hypotenuse. Tangent was your opposite over adjacent, aka SOHCAHTOA. Do y'all remember this?
Mm-hmm.
Now, what might be new to you is what's on the right-hand side. Okay? Cosecant, secant, and cotangent, okay, are known as the reciprocal trig functions. Okay? They're known as reciprocal trig functions. Cosecant is the reciprocal of sine. Remember, reciprocal in math means you flip, right? So as you can see, cosecant of an angle is your hypotenuse over your opposite. It is the flip of your sine. Okay? Secant is the reciprocal of cosine. It is the flip of cosine, so it's hypotenuse over adjacent. And cotangent is the flip of tangent, adjacent over opposite. Okay? So let's look at some examples that are going to involve using SOHCAHTOA and the reciprocal trig functions, different types of problems, okay? All right, let's start here, okay? It says find the exact values of the 6 trig functions of theta, okay? Shorthand the instructions and get down the triangle, okay? Really and truly is more about the triangle. That's the important part, okay? But we're finding the exact values of the 6 trig functions. There's 6 of them. There's sine, cosine, tangent, cosecant, secant, and cotangent, okay? And so when it's asking you to write down these exact values, they basically want the ratios, okay? That's what they want. They want the ratios. So, you have sine, cosine theta, tangent theta, cosecant theta, secant theta, cotangent theta. We want all 6. But in order to do that, I think we might need to label some of our sides, okay? Let's label our sides. Let's label our sides here. Remember, it's always based off of one of the acute angles that's given to you. Okay? So based off of that angle theta, theta is a Greek letter. It's in math it's used to represent an angle, so you'll see that often. Okay, it's just a circle. You just kind of go through and loop around. The 8 would be considered the what side? Very good. It's the opposite side, and the 15 is the adjacent. What does adjacent mean again? Right next to, beside. And then the 17 is the hypotenuse. So if you're able to label your sides and identify what they are, then writing the trig functions will be easy as long as you remember them. Sine is what over what? Opposite over hypotenuse. Our opposite side is 8. Our hypotenuse is 17. And we're done. That's the exact value for sine theta. Cosine theta. That's what over what? A little louder. So then that's going to be 15 over 17. Adjacent over hypotenuse. Tangent, the TOA part is what over what? Opposite over adjacent. So then that's 8 over 15. If you can get these three, then the reciprocals are just their respective ones flipped. Cosecant goes with which one? So it's the flip of sine. So it is the hypotenuse over the opposite, or 17 over 8. That's it. Secant goes with which one? Secant goes with cosine. So I flip cosine. That's 17 over 15. And cotangent, of course, goes with tangent, and then that's going to be 15 over 8. Okay? The main thing that students mess up on, and I had to recreate this photo because the one that I originally had they were lined up weird, is that sine goes with cosecant. And for whatever reason, students like to put S and S together and C and C together. Don't do that. S and C, C and S. Sine goes with cosecant. Cosine goes with secant. Okay? Questions on writing the ratios? Make sure you label your sides, okay? Here's one. It says if cosine theta is equal to 2 over 5, find the exact values of the 5 remaining trigonometric functions for the acute angle theta. AKA, find the rest. What do you think would be helpful for us to do this? A drawing, right? What am I going to draw? A triangle. Specifically a right triangle. I'm going to put that 90-degree angle in there, and I'm going to make one of my angles theta. It doesn't matter. It could be the one in the bottom left. It could be the one in the top. It doesn't matter. It really matters how you go about labeling the sides with your information. Cosine is 2 over 5. In general, cosine of an angle is what over what? Adjacent over hypotenuse. So indirectly, we were given the adjacent side and the hypotenuse in this triangle. Okay? So based off of my picture and where I put my theta, my 2 should go where? I'm going to label the sides, 1, 2, and 3. Where should the 2 go? On side 2, that adjacent side. So I'm going to turn that into like a real 2. And then the 5 should go where? Where the 3 is. Okay? So 2 is on my adjacent side. 5 is on my hypotenuse. The only information I don't know is my opposite. But what old school concept do you use when you know 2 sides of a right triangle and you don't know the third? Pythagorean theorem. Do y'all remember Pythagorean theorem? We need that here. Yes, we do need it, because in order to find any of the trig ratios that involve the opposite side, I need to know what the opposite side is. Pythagorean theorem is what? What's the formula? Where the C is what? The hypotenuse. C is always the hypotenuse. A and B are the legs. It really doesn't matter what goes in for A and B, but C has got to be the hypotenuse. We know the hypotenuse is 5 here, so we'll plug that in. That's 5 squared. 2 can either go in for A or B, doesn't matter. What's 2 squared?
4.
So I have 4 plus b squared equals 5 squared. What's 5 squared?
25.
How do I solve for b? Square both sides? So b equals what? It would just be the square root of 21. This is an equation that I'm solving here, so plus or minus. Don't forget about that. I have to harp on that because I don't want you to forget. However, we're talking about a side length. Can I have a negative side length?
No.
So then it's just going to be the positive. But don't forget about that, okay? Don't forget about that. Can 21 break down? Are there two numbers that multiply to give me 21 that add to give... what am I thinking? Sorry, are there two numbers that multiply to give me 21? That are perfect squares?
No.
So then that's it. That is just my opposite side. Questions? In my mind, I feel like I'm going through this fast because this is old. Well, are we good? Let's get these 6. Sine theta is what over what? Opposite of hypotenuse. So for this triangle, it would be... Very good. Can I actually, instead of going through it like this, can you guys do the rest and then I'll just check in? Okay. Okay, so I already know the cosine of theta is 2 over 5. That one was given to me. It did ask me to find the remaining 5. So we found sine together. Okay, let's see. Brian, what was tangent? Square root of 21 over 2. Very good. Now cosecant. What was cosecant, Paige? One more time. 5 over the square root of 21. Good. That's hypotenuse over the opposite side. Can we have a square root of the denominator? No. How do I get it out of the denominator? What do I need to do? Multiply the top and bottom by that square root. But once we do that, we just multiply straight across. That's going to give me 5 square root of 21 over 21. Because the square root of 21 times the square root of 21 is just 21. Make sure you rationalize your denominators. Also make sure that you reduce your fractions. When you're finding your exact values for these 6 trig functions, if the fraction can be reduced, you reduce it. Okay? Secant theta. Secant theta. Erica, what you get? Very good. 5 over 2. And Thomas, what about cotangent theta?
2 times 21 over 21.
Very good. That's after the rationalizing, because it would have been 2 over the square root of 21, but then you rationalize that to get 2 square root of 21 over 20. Questions on the values, right? The trig values. All of this today should be like a blast from the past, okay? Except I'm just giving you a little bit of extra with the reciprocal trig functions, okay? Find the value of x. Oh my goodness. And y'all, we get to use calculators now. How crazy is that? We're going to do a whole quarter about using our calculator. To find x, its side length. You determine which trig function is going to be the best one to use. You set up the equation and you solve, making sure you round to the 10th because that's what this problem is asking us to do. Remember, everything is based off of your acute angle. And number 1, what's our acute angle? 60. Please use 60. Don't try to figure out what that non-labeled angle is and try to use that, because heaven forbid you make a mistake. The x, is that the opposite, adjacent, or hypotenuse?
Opposite.
20 is the hypotenuse. Don't worry so much about the adjacent side because it's not labeled. I'm not concerned about that. I'm more concerned of finding out what the opposite side is. So based off of the information that I have labeled, which trig function has opposite and hypotenuse in it? Sine. Use sine, cosine, and tangent when it comes to solving for a triangle. Secant, cosecant, and cotangent are just going to mess you up, okay? So sine, you always put the angle beside the trig function. So the sine of your acute angle is equal to your opposite side over your hypotenuse. So that's going to be x over 20. And we solve for this, we solve for x by doing what?
Inverse. Sine.
We want to multiply both sides by 20, not inverse sine. You're thinking angles, that's next. Good that you remember though. So in my calculator, I'm going to type 20 sine 60 equals x. You will always see me write this line before I ever go to type it into the calculator, or ever I ask y'all to type into the calculator. So 20 sine 60, and I literally type it in exactly how I see it. 20, sine is located 2 buttons above your 7, right above that comma. Yes, we use commas in certain math classes with this thing. Okay? Then you type in the angle, close off your parenthesis. It's just a habit that I do. And then I click enter, and our answer should be rounding to the nearest 10.
Oh, 17.3.
17.3. Raise your hand if your calculator did not give you 17.3. That is okay, because this can very well happen, that you don't get 17.3. That's because these fancy little calculators, along with your scientific calculators, have 2 different modes. You have a radian mode and you have degree mode. Radian is the original measurement for angles. It was never degrees. Degrees came after radians, okay? So radian is always the default of any calculator. When you buy a brand new calculator or you reset your calculator, it always goes back to radian mode. So how do you change it to degree mode? You click the mode button. It's literally mode beside the second button. All these options. Don't get confused. Don't get too crazy. You want to go down to the 3rd line or 4th line that says radian and degree. You want to move your cursor over and you want to click enter to make sure degree is highlighted. If you ever borrow a calculator from me, you need to make sure that if we're doing something that deals with degrees, you're in degree mode. I have other classes that use both modes, so we switch, okay? You got to make sure, otherwise all your answers are going to be wrong, okay? All right. Let's label my sides. I'm basing my side labeling off of which angle? The 25. 8 is our what side? And x is our, again, we have another opposite hypotenuse, which means we're going to use which trig function? So we set it up. Sine of our angle, which is 25, equals 8 over x. Don't get it confused. X can be on the top or it can be on the bottom. In the orange, it was on the top, but this time it's on the bottom. To solve, get rid of that x value from the denominator by multiplying to both sides. Then you'll have x times the sine of 25 is equal to 8. To solve for x, you divide by the sine of 25. You can't just divide by 25. 25 is attached to that trig function. Do you notice the difference between what's in the orange and what's in the purple? When x is on the bottom, you're going to divide. When x is on the top, you're going to multiply. It's always like that. So when I go into my graphing calculator, 8 divided by sine 25, and yes, I always close it off. Did you guys get 18.9? 18.9. Questions? This doesn't just work with finding side lengths, this also works with finding the angles as well, okay? There's a difference when you're trying to find the angle versus trying to find the side length. You still set it up the same way, but you go about solving differently. Still base everything off that acute angle. 26 is your what side?
Opposite.
Opposite. 11 is your. What trig function uses opposite and adjacent? Tangent. So you set up the equation. Tangent, what's the angle? Theta. We don't know it. You can use x, it's fine. Equals my opposite side, 26, over my adjacent, which is 11. Now, anytime you are looking for an angle, anytime you're looking for an angle, you use the inverse of that trig function. That is the only way to detach the trig function from the actual angle. That's written with the -1 inverse notation of that trig function, and then you type in the fraction. So, to get the inverse, you press the second button and then that corresponding trig button, and it will literally pop up a tan with the -1. Second trig function, 26 divided by 11. I close it off, and I get my answer. And I'm rounding this to the nearest degree, so the nearest degree would be what number? Nearest degree. It would be 67. Okay? Questions? Anything related to the calculator? Do the second one. I base this off of my theta angle. 14 is the what side? And 16 is the hypotenuse. Trig ratio I'm going to use is sine, and I set up as sine theta equals. And because I'm looking for an angle, I use the inverse. So sine theta equals the sine inverse. Theta equals the sine inverse of 14 divided by 16. When you type that into your calculator, second sine, 14 over 16, and you got 61? 61. Angles. How many degrees are in a triangle? 180. And considering that one of the angles is right, that means the other two have got to be acute. If for whatever reason you type this in and you get an angle that's bigger than 90 degrees, you did something wrong. Okay? And it's got to make sense. Questions on trig. All right, let's talk about our special right triangles, okay? There's two different types. You got your 30, 60, 90, and your 45, 45, 90, okay? 30, 60, 90, this is the general makeup, and I actually think this is how it's written in the SAT book when it's given to you. This is not given to you in the ACT, okay? But it basically shows how these sides correspond to each other, and they only apply with these two special right triangles. The side across from your 30-degree angle is x. It's one length. The side across from your 90-degree angle is twice that length, and then the side across from your 60-degree angle is x times the square root of 3. Okay? So, when you are given a special right triangle, and you'll know because it will be 30, it'll be 90 and then maybe a 60 or 90 and a 30, as you can see in these two examples, you'll know it is a special right triangle. Okay? So, based off of this very first one that you have, if it's 30 degrees, the 4 root 2 is across from 30 degrees, that means it corresponds to this side, the x side. Which means to find the y side, I just need to do what to the x side? Multiply by 2. This is nothing but 2 times that shorter side. How do you multiply that? What does that become? A little louder. 8 square root of 2. You only multiply the number on the outside, not the number underneath the radical, because it's a whole one. Now this side over here corresponds to this one. Okay? So then that, I'm just taking my shorter side and multiplying it by the square root of 3. The square, 4 square root of 2 is going to get multiplied by the square root of 3. Now when I multiply like this, what does this become? 4 square root of 6, because you're multiplying. So 2 times 3 is 6. So x is equal to 4 square root of 6. Y is equal to 8 square root of 2. Because again, you double your shorter side to get your hypotenuse, and then you multiply your shorter side by the square root of 3 to get technically your longer side. Questions? All right? Let's look at this one down here, okay? Let's look at this one down here. I have a 30, 60, 90-degree triangle. The side I'm given is 20. 20 corresponds to which one of these sides? The circle, the square, or the triangle?
Square.
The square. So 20 is equal to 2x. It's twice my shorter side. So you would divide it by 2 to get my shorter side. Which one of these is my shorter side, the x or the y?
Y.
The y. So to find y, I'm going to divide 20 by 2, and I get, so my shorter side is 10, which means that this x value, my longer side, the side that's across from my 60, has to be the shorter side times the square root of 3, which would just be what? 10 square root of 3. Okay? I want you guys to try the last two. Try the last two. All right. So, if I look here, I see that the 7 is across from which angle?
The 30 degree.
The 30 degrees, which means that 7 corresponds with the x. So these are usually like the easiest ones that you could potentially get, okay? Especially if it's a whole number. Because your hypotenuse is just going to be what? That times 2, which is 14. And then, so that's what y equals. So then, and then x is going to be what? 7 times the square root of 3. That value times the square root of 3. Okay, those are the easiest kinds that you can get. Followed by the ones down here, where you're given the hypotenuse, you have to divide and then get the longer side. This last one, these are the harder ones of the types that you can get, you know, of course, depending on the number. Because this 12 is across from which angle? The 60, which means it corresponds to x square root of 3. Now be careful. This is x in concept of this particular triangle, not the x that's down here. Okay, so you have to be careful there. To find this value, to find this x, which corresponds to the shorter side, what do I have to do to that 12? I have to divide it by the square root of 3. Okay? Because technically 12 is equal to x square root of 3, based off of this triangle. When I solve, I divide both sides by the square root of 3. So then I'll have 12 square root of 3 is equal to my shorter side. I cannot have a radical in the denominator, so what do? Rationalize it. So then that becomes 12 square root of 3 all over
3.
which simplifies. What is 12 divided by 3?
4.
4 square root of 3 is the shorter side. Which variable represents the shorter side, x or y in that triangle?
Y.
So y is equal to 4 square root of 3. And if my shorter side is 4 square root of 3, my hypotenuse is how long?
8, 7,
Because I have to do what to it? Multiply by 2. So then x is going to be equal to 8 square root of 3. As long as you remember how the sides correspond to each other, you'll be able to find these respective side lengths. Okay? Let's look at the 45s. If you have a 45, 45, 90-degree triangle, that means that two of your sides are equal, hence the congruency side markings. Both of your legs are equal, so they're equal to x. Your hypotenuse is x times the square root of 2. So, in this particular problem down here, where one of the legs is 3, it's across from that 45-degree angle, which means I know automatically if one of my legs is 3, the other one has got to be 3. So that means that x is equal to 3. My y is going to be my leg times the square root of 2. So then y is just equal to 3 square root of 2. Okay? Those are your easier ones. Okay? Let's look at this one up here at the top. That 4 corresponds to which side of my 45, 45, 90-degree triangle? That x squared root of 2, it corresponds to this. So that 4 is equal to x squared root of 2. Which means I'm going to have to do a little bit of math to find out exactly what my legs are going to be equal to. How do I solve this? So I'll have 4 divided by the square root of 2. Then I'll have to what? Rationalize. I multiply the top and the bottom by the square root of 2. That will give me 4 square root of 2 all over. Does that reduce?
Yes.
So my x, my shorter my legs are going to be 2 square root of 2. Both of them. Try the other two. So this one, let's go this one down here. Okay? This 2 square root of 3 corresponds to your x, right? Okay? So then in order to find y, well actually I already know y, don't I? What is y? Because in a 45, 45, 90, both of the legs are equal, okay? But how do I find x? You multiply by the square root of 2, because basically I'm plugging that x in to that expression. What does this equal?
2 times the square root.
Very good. Over here, this 10 square root of 2 corresponds to which piece? The x square root of 2. So then that means if x square root of 2 is what 10 square root of 2 equals, well I can easily see that x should be what? My legs should be 10, which means that both of these, because they're equal, should both be 10. Questions on your special right triangles? A little bit of ACT and SAT review for you. Okay? Last thing we're going to talk about are our angles of elevation and depression. You guys have a white sheet that has this exact same picture on there, representing angles of elevation and depression. After teaching geometry and teaching Alpha 2 and pre-cal, when you go back over the angles of elevation and depression, the one thing that students forget is that these angles are created from a horizontal line, okay? Not a vertical line, not just some random arbitrary line that's in space. They always come from a horizontal angle. Pretend that I am this person scratching my head, okay? And I'm looking at students dead ahead, right? And let's say a student says something that just like blows my mind. From when I'm looking at that student, so I do that little emoji where like I roll my eyes up to the back of my head. That angle that my eyes have created is known as your angle of elevation. I was looking at you. You said something that made me say, oh Lord, I created an angle of elevation. You following me? Straight ahead, that line of sight, looking at you. Oh Jesus. Then I look up. That's an angle, okay? Or better yet, let's say I'm looking at you And then you don't answer my question. You do the whole you don't say anything. I ask are you guys done? And there's silence. Then I'm like, oh my Jesus. And I just put my head down. That angle I created when I was looking at you, oh Jesus, that is my angle of depression. Okay? But no matter what, it always comes from some horizontal line of sight, then to turn down. Okay? Always horizontal. Always horizontal. Okay? So, these angles of elevation and depression, you see how there's like those blank lines above the picture? I want you in your own words to write down how you're going to remember angles of elevation and depression in those lines. How are you going to remember those? Let's look at some of these problems. This is where your word problems come in, okay? So if anything, draw a picture to help you out. Every single one of these is going to be in the picture the picture's going to look like a what? A right triangle. The angle of elevation. Elevation, remember that's looking horizontal line going up. So the angle of elevation from point A to the top of the hill is 49 degrees. If point A is 400 feet from the base of the hill, how high is the hill? Well, I know I need a right triangle. And I need a point A. Where is point A going to be located? At the bottom? At the bottom. Yes, because think about it. It has an angle of elevation, which means I need a horizontal line. Then I got to look up. So that is my angle of elevation. It is 49 degrees. I'm looking, point A looking to the top of the hill, so this is my hill. If point A is 400 feet from the base of the hill, where's that 400 going to go? It's on the bottom. It's on that adjacent side. I like that terminology. How high is the hill? What am I looking for? I am looking for my opposite. If I can identify where my hill is in my picture, then I'll be good to go. And I like how you guys told me opposite and adjacent because you're basing it off of the 49-degree angle, correct? X is my opposite. 400 is my adjacent. Which trig ratio am I going to use? Tangent. Tangent, what goes beside tangent?
49.
Always the angle is equal to which over which? How do I solve for x? There you go, multiply 400 to both sides. So 400 tangent 49 is what I'm going to type into my calculator. 400 tangent 49 is what I'm going to type into my calculator. Did you guys get this?
Yeah.
Say hat around. So 460 feet. I think in the homework I tell you how to round, so you don't have to worry about what to do around. I gotta find it though. No. Let's look at one more together. From a top of a 120-foot high tower, an air traffic controller observes an airplane on the runway at an angle of depression of 19 degrees. How far from the base of the tower is the airplane? Well, I know I need a right triangle. What does this side of my right triangle represent in context of the problem? It represents the tower, right? Where's the plane?
At the bottom.
At the bottom. Okay. How tall is the tower? 120 feet. An air traffic controller observes an airplane. So I got my little air traffic controller person. He observes an airplane on the runway at an angle of depression 19. Now this is what I was talking about. Where is that 19?
Behind the man.
From the man,
You have to draw those.
draw that horizontal line out and then go down. That is your angle of depression. It's not inside the triangle. It always comes, and this is what I was worried about. It's always when a man's at the top of a building or an air traffic controller or in a plane, that students want to try to put that 19 on the inside. Okay? That's not a horizontal line, it's a vertical line. Okay? But, to help you out, horizontal lines are always parallel. Parallel lines cut by transversal create special types of angles back from geometry. Not 90, they have like fancy names, like corresponding. Huh? So 19 would be at the bottom as well. These two angles, what were they called? Alternate interior angles, yes. And the only reason why that happens is because the horizontal lines, they're parallel. This hypotenuse is creating a transversal and creates those congruent angles. So if you wanted to get the angle that was inside of the triangle you drew, there you go. Okay? How far from the base of the tower is the airplane? Where is that? Where's my X? It's the adjacent side. X is my adjacent, because this is the bottom of the tower. And 120 is my which trig ratio? Tangent. Set it up. Tangent what?
19.
Equals. Careful. This is right setup. So where's X?
On the bottom.
So it's not going to be like the last problem. How do I solve for X?
Can you just switch the X and the
You can, essentially. That is what you're doing. You're just switching places with them. You can just trade their places. Because that's all you're doing. You are dividing. This is like the work that goes along with it. So 120 divided by the tangent of 19. So X equaled
348.5.
0.5. Okay. What is this? Feet. Okay. I'm telling you, I'll tell you how to round. Me, I'm so prone to round the three significant figures. I saw that as 349. But like I said, we'll tell you how to round. Okay? We'll tell you how to round. I want you guys to do the last two, and we'll double check and see how you do. Draw a picture.
Look at my paper.
All right, let's go over these. So a ski run is 1,000 yards long with a vertical drop of 208. Find the angle of depression from the top of the ski run to the bottom. Okay? So again, when the person gets out of the little ski lift, okay, they hit the ground and then they continue to go down the hill. Okay? That is the ski run. That is 1,000. Okay? The vertical drop, vertical lines are ones that go straight up and down. That right there is your 208. There's your right triangle that we have created. Now when it says find the angle of depression from the top of the ski run to the bottom, that means I'm looking for an angle. Which angle am I looking for? Ooh, be a little more specific. Top angle, bottom angle. It's technically the bottom because when that person jumped out before they started going down that hill, so they looked out one last time before they said, oh, drop. So this would be your theta, and of course, alternate interior angles are congruent. That 1,000 is which side? The hypotenuse. The 208 is the what? The opposite, based off of this acute angle. Which trig ratio has opposite hypotenuse? Sine. So this is the sine of theta equals 208 over 1,000. And because I'm looking for an angle, what do I use? The inverse of sine. I type that into my calculator. I get an answer. What's my angle? 12 degrees. Okay, that's not too bad of a ski run. It ain't like a death drop. It's just 12 degrees. Okay, 12 degrees. Let's look at the last one. We got a cat trapped on the top of a tree branch. Okay, and the tree branch is 6.8 meters above the ground.
6.5.
What'd I say?
6.8.
Not bad. I don't know what I was thinking. All right, so here's your tree. It's 6.5 because he's stuck on one of these little branches. Okay? Now your ladder is only 6.7 meters long. Ladders, when you try to go up a tree, isn't the ladder going to be at an angle, slanted? Okay? Don't think you're going to climb a ladder vertically. You're going to fall backwards, okay? The ladder is going to rest on that tree. How long is the ladder? 6.7. There's your right triangle. It's asking you for the angle of elevation the ladder makes with the ground. Is my angle at the top or the bottom? Very good. Remember, from a horizontal line going up is angles of elevation. 6.5 is what side? And 6.7 is your... And which trig function are we using? Very good. Sine of theta equals 6.5 over 6.7. Because I'm looking for an angle, I do the inverse. Somebody give me this number. 76 degrees. And that is how we use TOA when we're dealing with right triangles. We talked about our special rights, and then, of course, your angles of elevation and depression.